Alright guys, I'm trying something new. I'm at OCCC. I have my phone on video. I'm using the document camera and my phone is pointing toward the computer screen. So I have them both here to make sure I'm always on the screen. I'm going to do my best. Hopefully this one won't be shaky, it'll be straight since I'm not having to hold it myself. So today we are doing section 6.1 and we're going to talk about basically an introduction to fractions and do several different things with fractions. So first of all, we need to know what a fraction is. A fraction represents part of a whole. I'm going to zoom out a little bit. A fraction represents part of a whole. A whole meaning a whole circle, a whole pie, a whole pizza, whatever it may be. So first of all, we need to know what a fraction looks like. So if I give you the fraction 3/5, for example, we have special names for the top and the bottom. The top number we call the numerator. The bottom number we call the denominator. Okay, and the numerator tells us how many parts, and the denominator tells us the name of the parts, or what kind of pieces they are. So we would read this as 3/5. The next thing we're going to do is represent shaded and unshaded parts of a region. Okay, so I'm just going to go down here. I'm not really going to number them, I guess. If I gave you something like this, it's not going to be a beautiful drawing, but let's go with it. Divided into 5 sections, 1, 2, 3, 4, 5. So the square is the whole. And if I shade some of them, okay, we're going to represent the shaded part and the unshaded part as a fraction. So let's put shaded equals and unshaded equals. All right, so how many total pieces are there? There's 1, 2, 3, 4, 5 total pieces. That's going to be our denominator on both. Out of the 5, how many are shaded? 1, 2, 3. So 3/5 are shaded. How many are not shaded or unshaded? There are 2 out of the 5. So we would say 3/5 of the whole is shaded, 2/5 is unshaded. Okay, let's do another one, but with different shapes. So if I gave you circles, how many total circles are there? There's 7 total circles. If I color some, okay, I'll put S for shaded. How many are shaded? There's 3 shaded out of how many? Out of 7. 3 out of 7 are shaded, or we can say 3/7. How many are unshaded? I'll put US for unshaded. There's 1, 2, 3, 4 out of 7 unshaded. So we can represent shaded or unshaded parts or specific things if we're asked. So the whole set, make sure we know, the whole set would be all 7. So if I had 7 out of 7, that would be one whole. Up here, if I had 5 out of 5 shaded, that would be the whole thing, right? All right, next what we're going to do is graph fractions on a number line. So I'll put graph on a number line. So we can represent fractions with objects, with regions. We can also represent fractions on a number line. So let's say the first one I give you is 1/4. Just draw a little line over here. Now again, I want you to visualize if this is 0 and this is 1 whole. Remember what I told you earlier, that a fraction, just a plain fraction, is part of a whole. So that means it's not even 1 yet, okay? Now the denominator is going to tell us how many pieces to divide from between 0 and 1. So if this says 4ths, that means it needs 4 spaces to get to 1. So from 0 to this would be 1, 2, 3, 4. Obviously that's not even, sorry about that. But this would be 1/4. 2/4, 3/4, and 1 is 1 whole, but as a fraction we would write that as 4/4. So if I wanted to graph 1/4 on a number line, I skip over and I would put the dot right there. Okay, let's do another one, but with a different fraction. I'm gonna go to the back here. What if I gave you 8/3? Now you may already know what kind of fraction, let me scoot that down. You may already know what kind of fraction that is. That's an improper fraction. We're gonna talk more about that here in a second. But let's draw a number line here. So notice on this, we can go ahead and talk about it. An improper fraction, the numerator is greater than the denominator, okay? So let's say this is 0. I need 1, 2, 3 would be 1 whole. 1, 2, 3, that would be 2 wholes. 1, 2, 3, that would be 3. Okay. So basically we just count how many the numerator is. The numerator is 8, and I already divided this line into thirds because my denominator was 3. So from 0 to the first tick mark is 1. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. This is where 8/3 would be. Okay, so this would be like 1/3, 2/3, 3/3, and so on. You could keep going all the way down, but 8/. So when you're asked to draw one on a number line, first look at your denominator, and that's how many you will divide into between 0 and 1, or between each whole number. Okay? The next thing we're going to talk more about is mixed numbers and improper fractions. So we just talked about 8/3, how that was an improper fraction because it was greater than 1 whole. Okay, so I'm going to give you another visual here. I'm going to give you 3 whole circles. I'm going to divide each circle into fourths, so that means I'm going to divide them into 4 pieces. Okay, and I'm going to shade this whole thing, this whole thing, this whole thing, and 3 of this one. Okay, so if I wanted to represent this as just a fraction, meaning just a numerator and a denominator, the first thing I look at is how many pieces is each whole divided into. Each whole is divided into fourths. So I know my denominator is fourths because that tells me what kind of pieces they are. And then all I have to do is count how many fourths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I could represent this picture with a fraction and say I have 11 fourths. In other words, if I was passing out fourths to people, I would have enough for 11 people. I could give each person a fourth. Okay? This is called an improper fraction because the numerator is larger than the denominator. Now, the word improper implies that something's wrong with it, that you're not supposed to do that. That's just the word they chose, I guess. There's nothing wrong with an improper fraction. It's just simply the fact that the numerator is bigger than the denominator, like I said. Now, what we're going to also talk about is a mixed number. So I can also represent this set here, if you will, as a mixed number. Okay, so let's talk about this. How many whole circles are shaded? So you agree that I have 3 whole circles here. There are 2 whole circles shaded, so 2 is going to be my whole number. 1 whole, 2 whole. Now in the third circle, not all of it is shaded, so I don't have 3 whole circles, but how many of this circle do I have? I have 3 out of the 4 pieces. Okay, so 2 3/4 is called a mixed number. It's a mixture of a whole number and a fraction, and what I want you to understand is that 11/4 and 2 3/4 are the exact same thing. It's just 2 different ways to represent it. It's kind of like you could have a dollar bill or 100 pennies. They're both a dollar, but it's just 2 different ways to represent it. So what we're going to do next is talk about how you can change from one to the other. And this may seem like kind of a random isolated skill, but it comes in handy later when you start doing upper level math. Sometimes you may have a mixed number and it's easier to do operations with improper fractions, so we can learn how to switch back and forth. Or you may want your answer written as a mixed number depending on the situation. So we need to learn how to go from one to the other. So first we're going to go from a mixed number to an improper fraction. Okay. So I'm going to give you the improper fraction the mixed number 2 8/9. There's nothing wrong with it right now, like I said, but we can change it to an improper fraction. Okay, and I use what I call like the check mark method, and I make this little sound effect. What we're going to do is multiply down 2 times 9 and add up, whatever that is, plus 8. So if you want to write it horizontally, what I'm really doing is 2 times 9 plus 8, all of that over the denominator. So one thing you notice, and look up here, both times our denominator was fourths, all of these pieces were still fourths. That didn't change. So that's one thing you should never miss on this, is that the denominator will always stay the same. Okay? 2 times 9 is 18. 18 plus 8 is what? 26. And like I said, you bring over the 9. So 2 and 8 ninths written as an improper fraction is 26 ninths. Okay, I multiply down and add it up. Here's the way if you want to write it horizontally. Let's do one more. What if we have 7 and 8 elevenths? 7 and 8 elevenths. Okay, again, we're going to multiply down, add up. If you want to write it the math way, 7 times 11 plus 8, all of that over what? What's my denominator? 11. 7 times 11 is 77. 77 plus 8 would be what? 85. And bring over my denominator of 11. So 7 and 8 elevenths is the same thing as 85 elevenths. Okay? Now we're going to do the opposite. I'm going to give you an improper fraction, and we're going to write it as a mixed number. Let's get this down. Okay, so next write improper to mixed number. All right, so let's say I give you the improper fraction 38 fifths. Okay, again, there's nothing wrong with it. It's improper, but let's say I want to write it as a mixed number. That means I want a whole number and a fraction. If you didn't know already, anytime something is written as a fraction, that's actually a division problem. It's numerator divided by denominator. Isn't that cool? That's where the division sign actually came from. Okay, something divided by something else. So you're always going to do the numerator divided by the denominator. So we're simply going, now we could type it in the calculator, but we're going to get a decimal, and that's not what we want right here. So we're going to do a little division house. It's very simple division, but I'm going to write it like this: 38 divided by 5. Okay, 5 will fit into 38 7 whole times. 7 times 5 is 35. 38 minus 35 is 3. Okay, so I have a 7, a 3, and a 5. We have to put that together as a whole number and a fraction part. Well, I already told you that 5 will always be 5. It will be the denominator. But here's a little trick to do it. We start at the top and go around the clock. So my answer is 7 and 3 fifths. 7 and 3 fifths. Circle that there. Okay, it divided 7 whole times. There were 3 pieces left over. What kind of pieces are they? Fifths. So that's how we got 7 and 3 fifths. Let's do one more. 43 sixths. Okay, right now it's improper. I want to change it to a mixed number. So I'm going to do a little division house. 43 divided by 6. 6 will fit into 43 how many whole times? 7. 7 times 6 is 42. 43 minus 42 is 1. To write this as a mixed number, I start at the top and go around the clock. 7 and 1/6. Just happened to be 7 again. Okay, so that was improper to mixed number. The next thing we're going to talk about is what it means if two fractions are equivalent. Equivalent fractions. What does the word equivalent mean? That means equal. Okay, so equivalent fractions name the same part of a whole. Let's put an equal out here. So if I drew a little rectangle here and I divided it into 2 pieces and I shaded 1 piece, if we wrote that as a fraction, we would say that's 1 out of 2 or 1/2. Half of the figure is shaded, right? What if I drew the same thing next to it? Now they're not going to be completely alike. I'll do my best. This time I divided it into 4ths, so if I shade these top 2, how many are shaded out of 4? 2 out of 4. But do you see that they're shaded the same amount? This one was divided into 1 piece, this was divided into 2 pieces, but the area that they took up was the same amount of space. So we would say 1/2 is equivalent to 2/4. I could keep on going. If I did one more, I'm going to do one more, you keep going forever. If I divided this one into 8 pieces, and again I shaded the entire top, the whole top we agree is all shaded, even though my drawing's not exactly the same. There's 4 out of 8 shaded. Okay, so 1/2 is equivalent to 2/4, and all of these are equivalent to 4/8. I could keep going on. 6/12, 5/10. Anytime the numerator is half of the denominator, it is a half fraction. Okay, so we agree those are all equivalent. Now, which one of these shows the least amount of pieces shaded? Okay, this one had 8 shaded, or out of 8, I'm sorry. This one had out of 4, and this one had out of 2. This one, if you see, I'm going to circle this because this is the one that's in what we call simplest form, which is what we're going to talk about next. So we agree that all of these are the same thing. 1/2, though, is the one that's in simplest form because it's the simplest, right? We only have 1 out of 2 pieces. So a lot of times when we're working with fractions, we're always going to put our final answers in simplest form, and that's what we're going to learn how to do next. So the first thing we had to understand is that all of these are the same. This was just the quickest way to write it. So think of it as if you had 100 pennies. If you had 100 pennies, that equals the same as $1 if I write a $1 bill. Now, if you were carrying both of those around, you have the same amount of money, but which one would be simpler to carry around? A $1 bill, because it's only one thing, and this is 100 things, but they're still the same amount, right? So it's the same thing with simplest form. So let's look at some examples with fractions of how we can simplify them. Now, you may have heard teachers or professors say lowest terms or reduce. They kind of quit using those words because it implies that you're changing the value. We're not actually changing the value, we're just writing it its simplest way. So simplest form is really the new way and the way we're going to describe it, let's say. Okay, so if I want to put a fraction in simplest form, let's start with this one. If I give you 10/16, okay? Now, once you practice this, and you're probably already familiar with this, but you'll get the hang of it. Immediately when I look at 10/16, I already know it's not in simplest form because they're both even. So anytime two numbers are both even, they can at least be divided by 2. There may be something more. So what we're going to do for simplest form is we're simply going to see what the numerator and denominator can both be divided by to get it into smaller or simpler pieces, let's say. So like up here, 4 divided by 2 is 2, 8 divided by 2 is 4, divided by 2, divided by 2. And this is where knowing your factors, like we talked about last week, comes into play. Now there's nothing else they both can be divided by in this case. They both can be divided by 2, and we have to make sure we do the same thing to the numerator and the denominator. 10 divided by 2 is 5, 16 divided by 2 is 8. And then I check again and look at 5/8. Now if I'm thinking about factors, there's nothing else, there's no other number that 5 and 8 can be divided by except the number 1. If the only thing they can both be divided by is a number 1, you're done, because we know if you divide something by 1, it stays the same. So 10/16 is the same thing as 5/8, but 5/8 is itself in simplest form. What about one like this, 36/63? Like I said, the first thing I always check is for if they can be divided by 2. In this case, 36 is even, but 63 is not, so I know they can't be divided by 2. And this again is where you can use your divisibility rules. Another thing, if you're strong with your multiplication facts, this won't be that difficult, but I noticed right away 6 plus 3 is 9. 6 plus 3 is 9. I know they're both divisible by 9 because of that rule we learned. Okay, you could also divide them by 3. So what I want to show you is 2 ways on this one. So if you pick the biggest factor, that's going to save you time because you'll only have to divide once. So if I do 36 divided by 9, my numerator is 4. 63 divided by 9 is 7. 4/7 is in simplest form because there's nothing else that 4 and 7 can be divided by. Now I want to show you the same one again. Let's say I didn't pick 9. Let's say I picked 3 at first. Divide them both by 3. 36 divided by 3 is 12. What is 63 divided by 3? 21. Okay, so it's not wrong if you pick a smaller number, but what you have to realize is look over here, and you always have to check again to make sure they can't be divided again. If you divided by 3 first, in this case, you would have to know, okay, those can be divided by 3 again, because I can divide 12 by 3 evenly and 21 by 3. 12 divided by 3 is 4. 21 divided by 3 is 7. So look, I still got 4/7 either way. This one just took me an extra step. So just know with simplest form, you can always get there, even if you don't pick the biggest divisor. Let's do one more. Let's do 77/88. You may already know right away what those both can be divided by. They can't be divided by 2. This one's not even. Anytime you have double numbers, they both can be divided by 11. 77 divided by 11 is 7. 88 divided by 11 is 8. 7/8 is in simplest form because they have no common factor to be divided by except the number 1. Okay, so that is simplest form. The last thing we're going to do is compare fractions. We've already talked about what it means if they're equivalent. And we know with comparing, we have 3 signs to use. Greater than, less than, or equal to. Okay? So when we want to compare fractions, we're going to use cross multiplication. This is the easy way to compare. Okay? So let's start with 1. Let's compare 5/10 compared to 4/8. Okay, so we're either going to put greater than, less than, or equal to in here. By cross multiplication, what we do is we multiply up, kind of like in an X. So 10 times 4 is 40. I'm going to circle that. And then 8 times 5 is also 40. What we do here is compare the two products. Since they both equaled 40, these are equivalent fractions. I put the equal sign. And you may have noticed that 5/10 and 4/8, they're both half in simplest form. So that's why 5/10 is equivalent to 4/8 because they both represent half. What about one like this? 2/7 compared to, I'm putting the circle here for our sign, 8/15. We're going to use cross multiplication. 7 times 8 is 56, circle that. 15 times 2 is 30. Okay, and again, we compare our products. What is 30 compared to 56? 30 is less than 56. Therefore, 2/7 is less than 8/15. Okay, and what about, let's do one more. 5/8 compared to 6/13. Okay, again, cross multiply. 8 times 6 is 48. 13 times 5, I didn't bring my calculator over here, I'm going to do it really quick. Times 5, 15, 65. Okay, so then all we have to do is compare 65 to 48. 65 is greater than 48. Therefore, 5/8 is greater than 6/13. Okay, so when you're comparing, we just want to use cross multiplication, compare the products, and that will tell you what sign to put in there. All right, that is all. Make sure you, after you take notes on here, to do your homework and email me if you have any questions.